Delivering zero downtime is hard. I'm not going to say it is easy because it is really hard. So you have to think through, and one of the things I tell my engineers, and this is something I learned at Yahoo, frankly. Until then, I wouldn't have known this because the previous model was you build some software, somebody else comes around and makes it run as a service. Doesn't work when you're a company like Yahoo or Facebook or Google. You have to run the service yourself. So when you write any line of code in there, you have to make sure it can run as a service. And that's actually what I ask my engineers to think about. So self-management means that when something unexpected happens in the system, which is going to happen, in fact, if there is any event which you think has a low probability of happening, I can guarantee pretty much in a large system, because of the law of large numbers, it is definitely going to happen. Okay? So this code needs to deal with it. So you have to think about it.
So this is kind of the storage equivalent of Murphy's Law.
Exactly.
If that outlying possible thing will happen, it's going to happen in a large system.
A device is going to fail.
Yeah.
A disk is going to fail. If you have enough disks, a disk is going to fail every minute or every hour or every day, depending on the size of your deployments. So you have to take into account when we build these systems to first of all test them. But first of all, build them the right way, and then make sure that you can actually handle those events, which are basically failure events of the hardware, and still run the service. And believe me, this is actually hugely important for operations, because the big difference between a self-managed system and one that is not is the following. Right? I'll give you an example. Let's say it's the middle of the night somewhere. It's always the middle of the night somewhere, and somebody, a node fails. Now, if that requires a manual person, a person to actually go and look at it and do something in a short amount of time, that is actually not a healthy system which you can keep running 24/7. This is what leads to failures. What would be better is a system which is able to somehow handle certain kinds of failures like that and keep running. In our case, for example, we re-replicate data when one node goes out among the other data. This actually happens, given now that we have so many customers in deployment. Once a month, we get this question from somebody, hey, we just lost a node. What am I supposed to do? And we go look at it and say like,
but their service is still running.
Service is still running.
They're still up and running.
They go like, what's and we go like, the rebalancing is now completed. You're actually safe to lose another node now. But please go get the other node back up if you have enough capacity.
Yeah.
So it's important to size it right. Okay. So if you size it and you always want to run at the limit, it's great to do it in a NASCAR, race goes to win the championship. You don't do that when you run a 24/7 service. You want to have enough, what I would call buffer, headroom. And then when things fail, the system has the software to be able to manage, because there's enough resources to manage it. It can now do things like, in our case, right, something like data rebalancing is happening in the cluster. Lots of data is being shipping back and forth, and transactions are happening. Our challenge is to make sure that the transactions continue unimpeded with low latency at the same time as data is being rebalanced, so it can protect you from the next failure that's going to happen. So you should run with enough capacity, with good software like ours, and then make sure that you can address these issues in a reasonable way.